Hi, everyone. Thanks for joining. My name is Einstein Millan. I am a solutions architect at WhitePrompt. And today I will be discussing Langchain, which is an LLM framework. So whenever you have a chance, give us a like and subscribe. Brief introduction to Langchain. Langchain is an open source framework for building applications based on large language models. It also provides a set of tools and abstractions in order to improve the customization, accuracy, and the relevancy of the information that the models generate. For example, developers can use Langchain components to build new prompt chains or customize existing examples. Langchain also provides components that LLMs can access, so you can access new data sets outside of the training of the model. Additionally, we can use different models, different large language models and chat models. We don't have to use OpenAI, for example. In fact, I was discussing that Hugging Face has a ladder analogous to the video game boards and ladders where the best models compete based on several metrics, such as the capacity to summarize, the capacity to do question answering, and much more. So why is this important? It is important because LLMs excel at responding to prompts in a general context, but they are not very good at providing stuff outside of their domain, the domain where they were trained under. Prompts are queries that people use to seek responses from an LLM. For example, a large language model can provide an answer to how much a computer can cost by providing an estimate, but it cannot list the computer parts or hardware that your company has. In order to do that, machine learning engineers have to integrate with large language models, with the organizational information, and apply some prompt engineering and perhaps fine-tuning to achieve the desired results. So how does it work? Langchain has a few abstractions and concepts under which it operates. It has a concept of agents, models, chains, prompts, indexes, and memory. I'm going to go over each one. So the LLM chain serves as a standard interface that allows for the interactions with a wide range of LLMs. The prompt construction is another component, refers to a variety of classes, functions designed specifically to simplify the process of creating and handling prompts. So if you work directly with the OpenAI API, you have to do, there's a lot of low-level coding, so to speak. There's abstractions here that allow you to inject different types of prompts and to work with different types of models, to use different types of tools. It makes it a lot easier. So to be clear, you could write a backend on your own just with Python, or you could use a framework like Django, Flask, or Fast API. There's a concept of memory. So we want to be able to talk to these models and to ask follow-up questions. And Langchain gives you a wide variety of options. You can use Redis store, you can use Postgres, you can use a buffer, you can use many places, you can even use CSVs if I'm not mistaken. You can use many persistence layers to keep your memory. There's also intelligent agents. So they have this concept of agents. An agent is basically an AI persona that has a prompt, but within the prompt, it has several methods. One of them is React, the other is chain of thought. There's many of them, but you give it a reasoning process where you tell it to use a tool for a specific task. So for example, if you were going to get the menu from a restaurant and there's an API endpoint, you could tell it, use the menu tool, and you give it a description where it says, use this tool when you want to get the information about a menu. So the prompt, along with the AI, along with the prompt, should be able to understand and be smart enough to determine what the best tool for the job from that list of tools. And then the tool should return a result, which it can parse and give you a response with. There's math tools. There's all sorts of tools. Math tools specifically, given the fact that large language models are not the best with arithmetic and mathematical operations. There is a concept of index. An index is basically methods for organizing documents. So everything that's text can be parsed and vectorized into a vector database. There's many of those that Langchain can interact with. You have Postgres with a PG vector extension, and you have many more. You have S3 locations. You can have Elasticsearch. You can use many databases and stores as indexes. And basically, the way it works, I'll show you in a little bit, and I'll talk about it in a little bit. But basically, it does a similarity search between two context vectors. A context vector is merely a one-dimensional matrix that holds information about sentiment and many other parameters related to a specific text. And that text can be a question, or the question is compared to whatever is in a database as a vector. And then it yields a statistical similarity, a list of statistical similarities, and it picks the best one for you. And it uses the large language model to parse that into human readable form. And that's the response you see from ChatGPT and many other OpenAI large language model tools. Finally, we have the concept of chain. A chain is a construct devised by Langchain, which may be sufficient, as it says here in the text, for simpler tasks. But for more complex tasks, you could chain these constructs together to provide a given answer, to provide a given response. So it basically divides and conquers for you. So here's how the vectorization part works. You have large documents. These can be any source of information, such as text, PDF, etc. They're chunked based on a strategy that you may define as an architect or as a developer. And then these chunks are stored as vectors in a vector store. So the user inputs a prompt, and it can interface with an OpenAI model or with any other large language model that we desire or that we pick, and that provides a reply for you. So what happens is it takes that information and it makes it human readable, and vice versa. It makes it computer readable and it makes it human readable. So basically the model is the interface. The question answering, that's exactly the way it works. You ask a question, you ask a large language model, which turns it into a query, and then the vector store returns a set of results that it picks to give you an answer. Now I'm going to show you guys a practical example. I'm going to vector. I have already ingested the Old Testament. I just picked it because it was large, hard to learn, or hard to digest corpus of text. And then I'm going to ingest the Quran, and I'm going to ask questions. You can do that with anything. You can do that with movies. You can do that with any text. I just find it interesting because I know very little about religion, and I figured it would be a good chance to learn. I don't mean to be political in any way. So, I've already put some commands. Can you see my screen? Do you see my command prompt, or do you still see the presentation?
We can see both.
Okay, good. I'm going to do the ingestion piece of the Quran, and basically this is just Python code, and I'm going to store it in a collection called Theology. I just downloaded this off the World Wide Web as a PDF, and I may fail. Yeah, it'll fail. Never mind. I have to connect to the VPN. It should take a few seconds to ingest into the vector store.
So what this command is actually doing?
So this command, thanks for asking, this command is taking a PDF of the Quran, and it's going to ingest it as text into a vector database. I've already done this for the Bible, so we can ask questions if this takes too long, but it shouldn't take that long. It's pumping data, as you can see, and I'll show you so far how it ends up in the database. So what Langchain does for us is it creates two tables. One is a collection, and one of them is the embeddings. So you can see it has something about meetings, something about theology, which is the one I'm making now, and some other stuff about meetings. And the way these are the columns, you can see the columns here, but I want to show you the columns in the embeddings database. And basically it connects to your collection, and it keeps the embeddings and other things in there. I'm going to run a quick query to show you guys. So it points to the collection ID, and you can see that this is a vector. This is basically a one-dimensional matrix that stores all sorts of information. These are just pretty much weights, and it contains contextual information about the text. It conveys meaning, human understandable meaning of those big vectors. You can see here, it keeps a copy of the document. It says, but the Lord saw that the wicked, and then stores all sorts of neat information. But just wanted to give you guys a feel for it. Some sort of a custom ID, UUID, and some metadata about the documents. That we any metadata that we want, such as the source. If it's a meeting, we can say who attended the meeting. We can keep all sorts of metadata related to that. Well, this is still going. So what I'm going to do is I'm going to pull up another prompt to ask it questions, so we don't waste. Oh, there, it just finished. Good timing. So now we should have information about the Quran, and we should have information about the Bible, and we can start asking questions. My cheat sheet over here. So I don't even know what this was. But this is in the title, so I just asked it what, I'm gonna go ahead and ask it what is, however you pronounce this. And I'm gonna point the collection that's involved in this query. So it's hitting the document store. It takes a few seconds because it's such a big text. By the way, feel free while we're waiting to ask questions if you have any so far. Oh, so you can see all the output. This is hitting the database, and then it says they didn't find any useful information, meaning that it couldn't find anything within the text, but it's found information from its own training about the Hebrew Bible. Now I'm going to ask another question. So there's some questions it'll answer, some of them will not. It talks about Mount Sinai, and I'm going to ask it questions about that. Then I don't know what to ask about I can ask a question about the Quran, I guess. I don't know much about that either. I wanted to show you guys how we can also impact the way we get feedback from the model. So there's retrieve here. So basically, lines 165 through 170 is to ask questions. And this is the wrong prompt. I guess I'm at the wrong folder. But anyways, here we can tell it to ask. It won't find any relevant information. Now I can tell it to, I can change the information here, and it would find relevant information. This is how we prompt the model, the same way you would talk to OpenAI. So it did find some information about Mount Sinai. So it says, according to the documents retrieved, here are some details about the event as described in the Islamic tradition. And it says it organizes it for you as a summary. So for example, Moses was called by God when he came to Mount Sinai, where he was told to remove his shoes. And then it tells you where in the Quran it talks about that. And I think this is pretty interesting use case, because if you don't know about one book, you can make comparisons about these theological events that are described in different scriptures and books. So it did find results based on that, even though the prompting was not directed to that. The prompting was directed towards meetings, but it was smart enough to deduce what I wanted and tell me where in the Quran this information can be referenced. And then the possibilities are endless. You can extrapolate this to many other applications. That's what I wanted to share as a practical example. I don't know if you guys have questions, because this is at the end of the presentation.
Did you show here anything, a way to store the conversation somewhere so the model is aware about the latest questions, so do a more detailed answer for you?
Sure. This proof of concept that I have does not have memory working on it, but Langchain explains a very simple way to do it. I usually store it in Redis, and it's injected as part of the prompt into the conversation by Langchain. I don't have it working in this example, but it should take about 30 minutes to an hour to implement. And then you can also run commands to clear the chat or do whatever you want with it. Sorry.
I see. And one more question about the vectors. Sorry, I think I made you this question some time ago. When you uploaded the PDF, at some point it's translated to vectors, and it's a list of vectors. It's not just only one, right? And this model, how would the model understand that a set of vectors belongs to the same topic? Let's say how they group the information, or from another perspective, let's say that you upload another document about cooking, and how those vectors are categorized in some way. And
yeah, I understand your question, and I can answer it. So there's several ways we can do that. One of them is when you vectorize, you can you create a collection. So let's look at the data here in the collection first. When I did the ingestion for the Quran, I called the collection theology. when I ingested the transcripts for meetings, I called that meetings. So we can make as many entries to the collection. And then when you vectorize it, the vectors themselves, which is in a different place over here, there's a relationship between the embeddings and the collection. That's one way to separate your information. But also your vector should also contain information. It's rich enough to contain sufficient information to convey human meaning. So even I'm pretty sure, I haven't tested it yet, but I'm pretty sure that even if you put them all under one collection, it would would be able to distinguish one subject matter from another. But to play it safe, what I would do architecturally is separate it by collections.
So the similarity search is between the question vector, right, against all the vectors that belong to some of those collections.
Yeah, yes. What happens is you ask a human question, it comes in human context. Let me go back to that slide. Oh, so this is your human question. The LLM converts into a vector because when you did the vectorization was done by that language model, that large language model. So when one specific thing we should all do is set the temperature to 0 so that it doesn't get too creative and it always gives you the same result given the same input. So in other words, to make it deterministic in nature by lowering the model temperature. So once that's vectorized, you can query your vector against and see how similar that vector is to whatever we have stored in the database. Statistically, we can set the cutoff of how many results we want it to come back with, statistically how close we want them to be. So if they're not 90% exact, then discard them from this query. Or we can play with that too, with that parameter. And then the large language model takes those vectors and converts it to a human readable answer again. And that's what you get.
Right. So what we are storing are the vectors that are the output of the transformation, but at some point we are sending the source plain data to some API. So at some point
Yes, sir.
it goes to them. Right.
Exactly.
And then from another perspective, since we are using a model that was trained with other features, I think you made a test as well with other languages, right? So you made the similar question, but in Spanish, and the model is able to answer to you, right? In
Yes.
French or something.
Yeah. Well, at least with OpenAI, I've tested it and it works because OpenAI has been trained with the information from the internet, and the internet holds all of our context, all of our meaning, all of our languages. So it's pretty effective in any language, most languages.
Great. Pretty nice.
Any more questions, anyone? Well, excellent. I want to thank you for your time and for attending the talk.